The 1800s can be called the time of the Renaissance of science. But what can truly be called the greatest theory of this time is Dalton's atomic model. Since the 8th century BC, the same model of matter hypothesized by the ancient Greeks, mainly Democritus, had been carried on. John Dalton, an English chemist, carried out experiments involving gases, and on the basis of the results and a few hypotheses, constructed an atomic theory, the first of its kind. The atomic model contained 6 main postulates. The first of these was one already thought of, that all matter is made of immensely tiny particles called atoms. Atoms are indivisible and may not be created or destroyed. The second was that atoms of a given element are identical in mass and chemical properties, and that atoms of different elements differ in these. This essentially means that an element like carbon remains carbon right down to the very last atom, but the properties of carbon cannot be the same as those of phosphorus. Simple enough. The third postulate of the theory was that atoms of different elements combine in simple whole number ratios to form compounds. The fifth postulate said that at times, atoms may combine in more than one ratio to form compounds. For example, atoms of carbon and oxygen form carbon monoxide as well as carbon dioxide. In addition to these, there was a sixth postulate, better known as the rule of greatest simplicity. This basically implied that elements having one compound would combine in the ratio 1:1, those having two compounds in the ratio 1:1 in the first and 2:1 in the second, and so on. The postulate was met with much flack and was omitted from the subsequent editions of the atomic theory. This theory was widely accepted, but some of its parts were widely debated as well. The first postulate was debated, citing the example of nuclear fusion and fission, but this suggestion was dismissed, as these were nuclear and not chemical reactions. The second postulate, though, was proved partially wrong with the discovery of isotopes and isobars. Dalton's atomic theory, though, was the first step towards developing the atomic model that was later improved by the likes of Thomson and Rutherford. Keep watching.